Okay, this is a summary of this particular video display up here, which was done by Brian Hughes of Microsoft, explaining that the Node.js event loop is not always so single-threaded. So this is a quick summary of timestamps and snapshots. If you want to see it, the link's included, so you can go and study it in a bit more detail. But essentially, we must first ask what multitasking is. And if we have a single core, we can see that only one thing can be done at each time, but it can move between one to the other, giving the appearance that things are running in parallel. But in fact, it's just time slicing. And multi-threading is if you have like two cores, then obviously you've got two threads, and then you can pass number of tasks to each. So if there are 4 tasks, each can do 2. So basically it will take half the time because it's got 2 cores. And we see that again in here. So processes versus threads, the timestamp up top here, you'll be able to see it down here on the bottom. The processes are like tasks, threads are where the processes are run. And in JavaScript, the event loop runs in only one thread. So that basically what it does is it passes off things to various tasks, but doesn't get involved in multi-threading itself. But C++ is a third approximately of the node, so that anything that C++ does, it can do either synchronously or asynchronously. And C++ will often run these things outside of the main thread. So if we look at the crypto code here, what's actually happening, this is synchronous, and if we look at the results to run 2 requests, it basically, when done synchronously, is done one after the other. This is a dual core computer, but because it's synchronous, it actually waits till one task completes. On the other hand, if we run it asynchronously, we can see that they can both be run in parallel, each core doing one at the same time, so it takes half the time. If we do 4 of them, each core can only do 2, one at a time. It's given 2 each. So it's basically doing 2, 1 after the other. But because the 4 are split into 2, it basically takes double the time and it can do it. Because Node.js uses what's called, also uses pre-allocated thread pool of 4. So when we come to doing 6, it has 4 thread pools. It can then obviously would do the 4 requests as such. And the last 2, 5 and 6, have to wait till all 4 are completed, and then it is done. So essentially what we're seeing in here is when there are 2 requests, they're done there. When there are 4 requests, each core can do 2 of them, so it goes to here. It can handle 4 requests, so each does 2, so it takes twice as long each, so it's half the time for 4. But when it comes to 5 and 6, it has to wait until all those 4 threads are done, and then it can do the final 2. And it's 125 approximately each for them, because each core has 1 thread that it can do for each of them. A different example using the HTTPS module, the bottleneck here is in fact the network. So when we do 2 requests, for example, it takes a certain length of time. Let's just drop that down here. And when we move to 6 requests, it makes no real difference because it's not the thread pool that's the bottleneck, but the network request. So essentially, and it's an oversimplification as he says, basically what will happen is Node is a central dispatch that may run things in its own single thread or may pass things to the C++. It may do it synchronously in C++ or asynchronously. So actually that's the thread pool that's passed off. And we'll have another video on a different talk, but actually this one here, this one was done by one of the developers on sort of Node, and we'll look at that later. But this is, as you can see here, Bert Belder, everything you need about the event loop, that there's mini callbacks and threads. So if we come back here, we can see what is actually done by this thread pool. DNS lookup, file system, we can see here that many different things are done it. So in this case, Node isn't single threaded, where those tasks can be done by the C++ core. So in a quick nutshell, in about 5 minutes, we've seen really that Node is single threaded, but it can pass things off to the C++ thread pool for certain types of things that C++ does, not for its own JavaScript executions.